And good morning, Ashley. And let's see here. Let me go to participants. Okay. Okay, Melissa, you're in charge now.
Okay.
That makes my life much easier. I really missed you yesterday. I was busy back and forth.
I'm sorry about that.
No, I'm so glad it makes me appreciate you more. Actually, I had a problem with it because somebody came on and it was not a name that I recognized. So I didn't just ignore it. I just said do not allow. It turned out it was Umar who was using a different device, but it had a very strange name with it. And that's what set me off. It would have been a regular name. I might have gone on and said, "Who are you?" But so he couldn't get on. It was like, so that took a bit of time. All right. Anyway, there are two problems on the board. Can you see them? Because I did them in blue ink, but I better just switch back to my black ink.
Yeah, they're a little bit like you can see them, but they're not like clear.
Yeah, I must buy more markers. Okay, I'm going to give you a few more minutes just to do these, and then um, we'll go over them and continue with what we were going over. Did anybody have any questions about the material that's on the Delta math quiz? Remember, that is not the radicals. It's not the square roots. It's the fractions. Don't forget, it has to be completed by, I think, 11 p.m. is what I gave as the time. If you have a problem and you can't complete it by then, for some reason, let me know. I can extend the time for you.
Professor,
Yes.
are the rational problems going to be on the quiz?
On the what?
Rationals.
The rational problems. Yes, the rationals are the fractions. Those are going to be on the quiz. What's not on the quiz are the square root problems.
Okay.
Make sure you get it done today, unless you, again, if you have a problem getting it done today for some reason, just email me and I'll work on it.
Good morning.
Good morning. How are you?
I'm good. Thank you.
No veo cuánto porque eso ni.
Natalie, Natalie, can you mute Natalie because there's a lot of background noise from her. Okay, let's work on these problems then. So the first one is a reminder of how we're going to remember how to solve an equation that has a radical in it. And the first thing you want to do is when you have a radical is make sure you get the radical part all by itself. Isolate the radical. So in order to do that, I don't want this 4 over here. I have to subtract 4 from both sides, which will give me that the square root of 2x minus 3 is equal to 3. Now, before I proceed any further, I look at this number. If there's an x there, I can't make that decision. But if you're left with just a plain number on the other side of the equation, it has to be a positive number, because the square root of a number, we always use that radical sign to mean the positive square root. It can't be a negative. Just like the absolute value can't be a negative, the radical can't be equal to negative. So therefore, if this would be a negative, I would stop right there and say there was no solution. But it actually happens to be positive. So the next step is to get rid of the radical, which is to square both sides. Remember, multiply each side by itself. Now, the side that has the radical, when I multiply the square root of 2x minus 3 by itself, the square root of 2x minus 3 times the square root of 2x minus 3 just gets rid of that radical, and I'm left with just plain 2x minus 3. Anytime you square something that has a square root over it, it undoes the square root. It gets rid of the square root. On the side that doesn't have the square root, I have to actually multiply it by itself. I have to do 3 times 3, so that gives me 9. Remember, if this would have had a variable on it, I would have, let's say, it would have been x minus 3, then I would have had to do a whole FOIL because I would be multiplying a binomial. Okay, now this is a simple equation that I solve. I add 3 to both sides. It gives me 2x equals 12. And when I divide by 2, I get x equals 6. I think, Cheryl, you put that on the chat. Yes, x equals 6 is the answer I get from solving the equation. don't forget to check. Radical equations need to be checked. Most of the time they will work. Most of the time it's okay. But every so often you get what's something called an extraneous root. You've done all the right work, you've done it completely right, but the answer doesn't work and you cannot accept that answer. So here, when I replace x with 6, I'm going to get 2 times 6 minus 3 plus 4 equals 7. Remember, always go back to your original equation to check. So this is 2 times 6 is 12. 12 minus 3 is 9. So this becomes the square root of 9, which is 3. And 3 plus 4 equals 7 is true. So this is the correct answer. Your answer for this is the one number x equals 6, or 6. You wouldn't even have to put in the x. I'll be giving you examples from this on your Delta Math homework over the weekend for Tuesday. So look out for these type of examples, like number 2, where we have 6 minus 7i times 5 plus 3i. We want to multiply what are called complex numbers. Whenever I see this I, and it's always a lowercase I, usually written, if it's printed, it's written in italics. It's not written like a regular I, to indicate it's you could write it like this. But the problem with writing it like this is if they don't make that dot very bold, you may miss it and think it's the number 1. I is not the number 1. Remember, the value of I, which we usually write either in italics or as a script, either way they might be used, is the square root of -1. It's not a real number. It's a number that doesn't belong in our regular number system that we talk about all the time, that we've been using on a regular basis. The real number system, it's all the numbers that are on the number line. Those are the real numbers. This I doesn't belong on that. It's not one of those numbers on the number line. It's a special new number. It's part of what we call the complex number system. And what we have to remember is that it's equal to the square root of -1. And also that when we get I squared, we're doing the square root of -1 times the square root of -1, and we're getting -1. So that if I end up with a plain I leave it there. But if I come out with an I squared, I replace it by its value -1. We don't replace it, the square root of -1, but we do replace the I squared because it has no radical in it. It's just plain -1. So when I want to multiply 6 minus 7i times 5 plus 3i, it's 2 binomials. I use all the regular rules of algebra. I'm going to use FOIL. So first, 6 times 5 will give me 30. Outer, that's the O. 6 times 3i, that gives me 18i. I is inner, -7i times 5, which is negative
35.
And finally, -7i times
Ms. Robinson,
Plus
I just
21.
sent you Ava's writing. Those are in her own words.
21
Okay.
squared. And don't forget, whenever you have an I times an I, you're getting an I squared. I think that's the most common error. People forget they do I times I and they just write I. It's not, it's I squared. And the I squared, then we replace by -1. So we get -21 times -1, because these are just regular numbers now. So this becomes a positive 21. And I combine the like terms, which is the 30 together with the 21. They don't have anything next to them. They're just regular numbers. That's
51.
51. And 89 minus 35i, those are also like terms because they just have i's, and that gives me minus.
Negative 17.
What are you reading?
So my final answer becomes 51 minus 17i. So that's what we had started with yesterday. We're now going to go, unless there is a question, we're going to go on to the next. Can I erase this now? Any questions?
I have a question with the first one.
Okay, what else?
Yeah,
Professor.
sure, Devon.
Can we get another example like that? Because I got a different answer than say.
Like this one?
Yes, please.
Okay, let's try one more
Another reason.
radical equation. Okay, I'm going to erase this and give you another one. Suppose I have x plus 7 plus 5 equals 2. Okay, I'm going to give you a minute to try that.
Or you can take a picture.
Professor, I got no solution for this. I don't even know if that's right.
Right, there is no solution to this.
All right.
Because the first thing you have to do is bring the 5 to the other side so that you get the square root of x plus 7 equals negative 3. And when you have a square root equaling a negative number, there can be no solution. That doesn't make sense. So what would, Devana, what would you have done if this would have been a positive 3? How would you have gone from there?
That's where it seems like the ones where I have no the ones that have no solution, they're pretty. I pretty understand those, but the other ones where I have to do more work. Okay.
Let's change it to this is the plus 2 over here, and this is the 5 over here. See what you get with that. Okay, what do we do first here? Should we bring this 2 over to the other side?
Mm-hmm.
So that'll give me the square root of x plus 7 equaling 3. Do I stop right here, or can I go further with this?
Is this the class question or you asking for Devano?
I'm asking anybody who wants.
Okay.
All right, so
Trying
we're
to
just
get.
waiting, I think, for everybody.
Can we
I
go
mean,
further with this?
you can square it, right?
Right.
Mhm.
Since this is a positive number, this makes sense. You could have the square root being positive, so then we're going to square both sides. What are we gonna get on this side?
The x square root x plus 9 equals 9.
You upload it on Google Classroom. Do you
Once we square it,
What?
we're no longer left with that radical sign.
Mm-hmm.
What about on the other side? What do we
Equals
left?
9.
That one didn't have a radical sign, so I have to do 3 times 3. That gives me the 9. You see, where there's the radical sign, when you square it, all you do is basically erase that radical.
I see. Okay.
Where there's no radical sign, then you have to actually go to the prop and multiply by itself. 3 times 3, that gives you 9. And of course, then you can just solve this equation and you get
And
an
the answer is 2.
So when all of a sudden they change.
Okay.
It always been that
yeah,
way?
when you're solving it, after you finish solving it, that you have to check. If I check it, this will be 2 plus 7. That gives you 9. And the square root of 9 is 3. And 3 plus 2 equals 5. It does check, but you must check it. Is that better now? Is it clearer?
Yeah. Yeah. Thank you so much.
Professor,
Okay,
What
so
happened-
let's try an
Professor,
example where we have to do division.
Sorry. Professor, I think someone's trying to ask a question.
Jonathan, what was your next question?
No, I think someone here was trying to ask you a question.
Oh, okay, I didn't hear.
this is Kashira speaking.
Yeah, hi, Katura.
Professor, what happens when you check the work and it's not equal to the original answer?
Then you have to throw out that answer.
And would it be no solution?
And so there are a number of possibilities. Sometimes you end up with 2 answers. Maybe after you squared it, you got an x squared in your equation. It was a quadratic equation, and therefore you might have 2 answers. And one of them checks and one doesn't. Then you just write the one answer that checks. If there is only one answer, or and it doesn't work, it doesn't check, or let's say there are 2 answers and neither of them check, then there is no solution. And you just write no solution. Again, you can either write it as no solution like this, writing out the words, or you can use this symbol. It's a Greek letter, but it's basically the 0 with a line slash through it. That is the symbol for no solution. Does that answer your question, Katura?
Yeah.
Okay. All right, so let's go on to another problem. This is going to the last thing that we talked about yesterday, which was what do we do when we have complex numbers and we want to divide them? Let's say I gave you 3 plus I over -5 minus 4I. And I said either the term would be divide, or sometimes it says simplify, or sometimes it says rationalize the denominator. It doesn't matter what instructions they give you. What you have to know is that you never want to be left with either an I in a denominator or a radical in the denominator. Is there anybody else who's having trouble hearing me? Can everybody hear me?
Yes.
Yes.
Okay, Natalie, are you still having problems? Natalie, I think it's somebody, Natalie. don't know, I guess she's having trouble with her audio. Okay, so do you want me, I'm gonna give you a minute to try, see if you remember what we should do in this case. If not, we'll work it out together in any case. But I'm gonna give you a minute to try it on your own. Okay, while you're doing this, I'm actually gonna take attendance because not waste too much time here. Azia,
Yes, Professor.
Nashia Allen, and Abelkis Baez, Emma Benedict. Emma,
I'm here.
good morning.
Morning.
Messiah. Messiah. Corey. Corey Brown.
Here, I'm here.
Good morning.
Good
April.
morning.
Good
April.
morning.
Good morning.
Good morning.
Khadija. Khadija. Umar. Umar. Yakima. Cheryl, I know you're here. Stacia. Stacia. Denisha. Devana, I know you're here. Natalie. Natalie, do you hear me now? I guess she's still not hearing me, but she's here, I know. Erica,
Good morning, Professor.
good morning. Jonathan, I missed you yesterday, Jonathan.
Oh yeah, Jennifer, she told me I had a doctor's appointment.
Yeah, you told me. I'm glad you're back.
Thanks.
Luke. Luke here. Layla. Layla,
Fucking nuts, bro.
what?
Oh, she put that was
Ashley. Ashley. Okay, Luke, Luke, I see came on, and Ashley, did you answer? Hello?
Yeah.
Hi. Okay, I'm glad you're on. Are people having trouble connecting, or it's okay? Katura? Katura? Hi, good morning. Jennifer,
she's away, but she'll be back Tuesday, she said.
okay.
Mhm.
Rachel,
Hello, Miss Pearl. Are you doing attendance?
yeah, hi, Matthias.
Oh, this is Messiah. Sorry, I just came.
Okay, I'm changing you.
But unfortunately, I can't stay for too long. because my mother's funeral is today and I have a lot of stuff to prepare for.
Oh, no, I'm so sorry to hear you.
I'm
Thank
so
you.
sorry, Messiah.
I'm
Thank
sorry.
you.
Condolences.
I'm so sorry to hear.
Thank you. Thank you.
Jesus.
God should comfort you.
Thank you.
I'm so sorry to hear it.
Thank you, Miss
Rachel,
Pearl. Say it again.
is Rachel Seeley here? All right. Messiah, whenever you have to leave, just leave. And just when you're ready to, you feel you're ready to get back,
Okay.
just let me know and we could either meet together or whatever, so we can, if you have any questions or things, we can go over it.
Okay.
Think of any way I can help you out.
All right. Thank you.
Okay, Umar, I see that you got on. Okay, let's work on this together. Whenever I see a radical in a denominator or an I, which is essentially a radical, it's really, I is just a symbol for the square root of -1. What we do is, if we see that there are two terms, if there's just a single term, like it's just I, then I just multiply by the I. But if there are two terms, if your denominator is a binomial, what you have to multiply by is what we call the conjugate of the binomial, which is the identical binomial, except that the sign in the middle gets changed. So the conjugate of -5 minus 4i is -5 plus 4i. Notice I didn't do anything with this sign in front of the 5 because the conjugate just affects the sign between the two terms. Of course, whatever I do to the denominator, I have to do to the numerator as well. So I have actually, I mean, it's a little bit of work, because I have two binomials that I have to multiply on the top and two binomials that I have to multiply on the bottom. But on the bottom, and I'm going to do that first, since these are conjugates, I can save myself a little time because I know that all I have to do is multiply the two first terms together, the -5 times the -5, which will give me a +25, and the -4i times the +4i, which will give me -16i squared. I don't bother with the O and the I, the outer and the inner, because they cancel each other out whenever you have conjugates. Again, to finish this off, on the bottom, the I squared I know is going to be a -1. So this will become a -16 times a -1, which is a +16. So my denominator actually becomes 25 plus 16, which is the real number 41. And I see by multiplying by the conjugate, I have rationalized the denominator. Rationalize the denominator means make it into a regular, plain, old-fashioned number that we see on a regular basis. Well, yes.
I'm sorry, it's Jonathan. I have a question. So the 25 minus 16i squared, that's for the bottom, correct? The denominator.
That's just the denominator. So I was just going to say, I just taken care of the bottom.
Okay.
I have to go back and do the top.
Okay.
The top is more work. That's why I did the bottom first.
Okay.
The
Thank you.
top is actually two binomials. They're not conjugates. I actually have to use FOIL. So here's my bottom. I know came out to be 41. You'll see, I usually do the bottom first because I know it's going to be easy, so I do it. The top, I'm going to have to be very careful to do the FOIL carefully. First, 3 times -5 is -15. Outer is 3 times 4i, which is 12i. Inner is I times -5, which is -5i. Remember, it's just like I'm doing 2 regular binomials. And finally, last is I times 4i, which will give me 4i squared. Don't forget that I times I gives me I squared. So that's what I get by doing FOIL on the top. And again, now I remember when I have an I squared, the only thing that's different about this than regular algebra is that whenever I see an I squared, I is not a variable. It happens to have a specific value. We just use a letter for it for simplicity. But 4 times, since I squared is -1, this becomes 4 times -1, which is -4. And now I work on the top. What do I have on the top? So the like terms are the -15 and the -4, which together give me -19. And the I terms are 12i minus 5i, which gives me positive 7i. And you put that over your denominator of 41. And you can even leave your answer written this way, but very often they're written in what is called A plus BI form, which means that you separate and put -19 over 41 plus 7i over 41. That would be what's called. So either one of these answers is perfectly valid, good answers. Again, if they ask for A plus BI format, they want it separated, not over one denominator. Is there any question about this? Okay. So where do we go from here? Well, one thing I want to go for from here is we really now have completed working with radicals. Again, we concentrated on the square roots. We talked about simplifying square roots, multiplying, dividing, solving equations with radicals with square roots. And then we talked about what happens if we have a negative inside our square root, and we introduced this new number I. I'm going to talk about now, I'm going to go into the next chapter. The next chapter is solving quadratic equations. All the work that we do in each chapter is because it's advancing us. It's telling us, giving us material that will enable us to do more of what we need to know. So if you notice, it's been like a bunch of steps on a ladder. You can't skip a chapter because you needed, let's say, chapter 4 to be able to do chapter 5. You need chapter 5 to be able to do chapter 6. We need chapter 6 to go on to chapter 7. I'm not leaving chapter 6 totally. There's still some material that I'm going to want to cover in it, but I do want to show you how what we've just learned will be helpful in chapter 7. Now, what is chapter 7 about? Chapter 7 is about solving quadratic equations. Hey, wait a second. We've done quadratic equations already. Why are we coming back to the subject of quadratic equations? Because it's so important. I think at this point, any linear equation, any type of equation that doesn't have any exponents in it, you could solve. It might take extra work. It might be hard because it has decimals in it or it's fractions in it, but you would be able to solve it. What about quadratic equations? Remember, a quadratic equation is something that has an exponent of 2. We're not at the point where we could solve any kind of quadratic equations. The only type of quadratic equations that we could solve were those, or the only type that we actually covered were those that it would be possible to solve by the means of factoring. But we also talked about where you could solve a quadratic equation using the quadratic formula. When we use the quadratic formula, that's what I'm going to go to right now. We saw in the quadratic formula, part of what you had to do was take the square root. That's part of the formula. The quadratic formula, if you remember, is x equals, you don't have to write this x equals, this is the important part, negative b plus or minus the square root of b squared minus 4ac over 2a. So there obviously is a part of using this formula is being able to use a radical sign and how to figure out radicals. What I'm going to show you now is how we could use this formula even if it would not be possible to solve the quadratic equation by factoring. So I'm going to take an example that looks like this. And suppose I gave you x squared plus 6x equals negative 3. Suppose I gave you this quadratic equation and I told you I wanted you to solve it. I know it's a quadratic equation. I don't have to tell you it's a quadratic equation. I know it's a quadratic equation because it has that x squared in it. And I know when I want to solve it, the first thing I want to do is I want to are you having problem with the
Yeah, because I guess it's me. I just got kicked.
I don't know why there's problems today. Seems, did Natalie get back on? Did she get her? Sometimes you just have to restart it. I don't know why. Are you okay now, Clary?
Yeah.
Yeah, okay.
My internet is fine. It's just you have to have it like cutting out for a bit, but it didn't cut out in this case. So I was confused.
Okay. We're talking about, remember the quadratic formula?
Yes.
Okay. I wrote it on the board. I want to do a problem using quadratic formula. It's a review. What I said in between, if you missed it, it wasn't so important. The important thing is we have a quadratic equation. We know it's a quadratic equation because it has an x squared. We want to solve it. So I know when I want to solve a quadratic equation, the first thing I want to do is get it equal to 0. So I'm going to add 3 to both sides. So this will give me x squared plus 6x plus 3 equals 0. And my next step usually is to factor. Break it up into 2 parentheses so I can set each parentheses equal to 0. And in order to factor it, I'd have to get the AC. That's 1 times 3. My AC is equal to positive 3. Usually I don't even bother writing this anymore, which means if I want to factor it, I've got to get 2 numbers that are going to multiply to 3, but when I add them, they're going to give me 6. And there are no such numbers. Remember, we're talking about whole numbers. We're not going into fractions and decimals and things like that. We want 2 numbers that multiply to 3. Well, that would be 1 and 3. Those are the factors of 3. But 3 plus 1 don't add up to 6. They add up to 4. In other words, I gave you an example where it's not possible to factor. If the question was factor this expression, x squared plus 6x plus 3, the answer would be, it's not possible. It's what we call prime. It's not factorable. But then how do I solve my quadratic equation? So I can solve my quadratic equation if I know I can always use the quadratic formula. Let's see what happens when we try the quadratic formula on this example. Okay, the first thing before I want to use the formula is to write down what my A, my B, and my C is. Now, do you have to write it down? No, but you have to know what it is because you're going to have to put it into the formula. I always like to write down so I keep track of what I'm doing. Remember, I only write down the A, B, and C when I have it equal to 0. The A is the number that's in front of the x squared. Well, there's no number there, so that has to be 1. The B is the number that's in front of the x, so that has to be 6. And the C is a number that stands alone, and that has to be 3. None of these had negative signs, so therefore, wait a minute, excuse me. Okay, and like we did before when we used the formula, we're going to substitute these numbers into the formula. So it's going to be negative. Here's my B. My B is 6. So this is negative 6 plus or minus. Now here comes my square root, B squared. So that's 6 squared. That's my B. Minus 4. A is 1. And C is 3. And this is all over 2a, so 2 times 1. So all I've done now is I've replaced the letters by the appropriate numbers for that equation. Now let's simplify. First of all, this just becomes -6, so that's okay. Then we have this plus or minus sign. We remember what that means. And then we have the square root here. Well, let's figure that out. That's the big, the most work involved. 6 squared, well, we know that that's 36. Minus 4 times 1 times 3. So 4 times 1 is 4, times 3 is 12. So that becomes 36 minus 12, which is the number 24. And that all goes over 2 times 1, which is 2. And what's different about this that we haven't had before, when we used the quadratic formula before, the number inside the radical sign always was a perfect square. In other words, we knew what the square root of 24 was. And I'll tell you a little secret. Anytime your example is not going to be factorable, the number inside the radical will turn out to be a number that is not a perfect square. It'll be a number that is what we call irrational. How do we leave our answer? So that's the next question. Do I leave my answer just like this? And the answer is no. What we have to do is try and simplify the answer. So sometimes we want to simplify the answer, and sometimes we want to get the answer as a decimal. And I'm going to show you how to do both of those things. So I'm going to erase this. Can I erase this part so I can have the use of the board? Okay. So here's my answer that I got. -6 plus or minus the square root of 24 divided by 2. Now, the square root of 24 is not a perfect square, but it can be simplified. Remember, that's something we learned just how to do in this chapter on radicals. This chapter, the square root of 24, what two numbers are multiplied to 24 that one of them is a perfect square is 4 and 6. And the square root of 4 is 2. So this could have been written as -6 plus or minus 2 radical 6 divided by 2. And what we want to do is we want to simplify. Now, what we have in the numerator is a binomial. It's either this -6 added to this or it's subtracted. So it's definitely a binomial. And it's divided by the number 2, which is a monomial. And if you remember when we did a division of a polynomial by a binomial, what we did is we divided each term. We did the -6 divided by the 2, plus or minus the 2 radical 6 divided by 2. In other words, we can simplify this fraction if we can divide every single term on the top by the 2 in the bottom. Well, the 6 divided by 2 is 3, so that gives me -3. And here the 2 divided by 2, remember when you're dividing, you divide numbers outside the radical by itself. So that just gives you the 2 divided by 2 cancels, and I'm just left with plus or minus the square root of 6. And that's your answer in simplest radical form. Now, just as a matter of fact, sometimes when they'll give this question, let's say they'll give this question on a final, they'll give you the answers either written like this, -3 plus or minus the square root of 6. Oh, excuse me. Hello? Okay. Hi, sorry. Okay, so as we said, we could leave our answer as -3 plus or minus radical 6. We could also write it, sometimes on a test, you'll see it not written as in this form, but written as two separate answers, as -3 plus radical 6 as one answer, I'm sorry. And your other answer as -3 minus radical 6. So you could, instead of writing it the shorthand way that we write it, which is with a plus or a minus, we just write it each one separately, because that was what that plus minus means. It means one answer is when you're adding the radical 6, and one answer is when you're subtracting the radical 6. In other words, even though it was impossible to, the board is not clear. Okay,
The connection is breaking up a bit.
I don't know. Only this one has, if he's using something. Stop it. Stop it. Stop it. Are you on, my connection on Zoom is breaking up. Are you? And he's not on the computer, so I don't know what that is. Sorry about it. Okay. Let me just, I'm gonna write your answer. Your answers were -3 plus or minus the square root of 6. Again, or you could write it separately as -3 plus the square root of 6 and -3 minus the square root of 6. But there, original problem was not, would never have been able to be solved with using just factoring, but using the quadratic formula and our knowledge of working with square roots enabled us to get an answer to this question.
Hey, Miss Pearl, it's Messiah. I'm leaving.
Okay, sorry about your whole.
Thank you.
I can't believe that he was even got on a day when he has to go to his mother's funeral. Wow.
Yeah, sad.
Okay, I want to do another example. I hope that Cheryl, that'll make it more understandable. Because I would say of the whole, of everything that we've learned this term, that what you really have to take out of this, obviously, whatever we did, you have to be able to do on the final. But the most important thing to you in terms of actual knowledge that you're going to port to a next math class, and I think most of you are going to be going on to 151, which is pre-calculus, you have to be able to solve a quadratic equation. You came into this course knowing how to solve a linear equation, a regular old-fashioned equation. You should go out of this class being able to solve any quadratic equation, any equation with an exponent in it, you should be able to solve if you have an x squared, because you should be able to use the quadratic formula. Okay, so I'm going to do another example. Not exactly the same thing, but again, just to give you an idea of what to do when you have a quadratic equation and you cannot factor it. Okay, I'm erasing this. I know I'm erasing the quadratic formula, but I'm going to put it all the way up here. So I'll have it as a reference, negative b plus or minus the square root of b squared minus 4ac, the whole thing over 2a. That is so important that at this point, you should be able, if I would wake you up in the middle of class because you fell asleep because I was so boring, and I asked you what's a quadratic formula, you should be able to say it even in your sleep. That's how important that formula is. Okay, and that, as I said, probably the most important thing that you want to take from this course. So let's say I gave you this equation. X squared minus 4x equals negative 5. Okay, I am going to give you a few minutes to work on solving this equation using any method you think you could work. I'm going to give you about 5 minutes to try it, and then I'm going to do it with you. Okay, let's start working on this together. I look at it, it looks like a regular quadratic equation. I know I have to get it equal to 0. So I'm going to add 5 to both sides. That's going to give me x squared minus 4x plus 5 equals 0. Anytime you want to solve a quadratic equation, you want to get that into what we call its standard format, getting everything on one side equaling 0. It's a quadratic formula because it has an x squared. We know we've got to get everything equal to 0. And usually what I try to do is factor it.
Professor,
Can you see the board okay now?
that threw me off. Why there's a -5 and a +5?
Because it's on the other side. You have to bring it to the other, you want to get it equal to 0. So this is a -5, and you have to add 5 to get it to the other side, just like a regular equation. Did I answer your question?
Yeah.
Okay. So I'm going to try and not to fill it up so much. I'm going to hopefully, unfortunately, these problems take a lot of steps. So but I'm going to try and leave space so the board will be clearer. Okay. So step number 1, it wasn't equal to 0. I've got to get it equal to 0. That's standard practice when we see that we have a quadratic equation. Now I want to I start to factor it. And I know that my AC is equal to 5, because this is 1 and this is 5. So I would need two numbers that multiply to 5, but when I add them, because this is positive, so when I add them, they're going to give me 4. That doesn't make sense. When the two numbers that multiply to 5 are 5 and 1. And when I add them, they don't give me 4, they give me 6. This cannot be factored. I know that everybody was going to say, oh, a +5 and a -1. But then I'll get a -5 and this is a +5. It looked so simple, but when I actually tried to factor it, it couldn't be factored. Until now, I'd have to, unless I know the formula, I can't solve it. But now I'm going to use the formula. So to use the formula, I'm going to write what my A, my B, and my C is. I'm going to put it over here so I can substitute them in. The A is the number in front of the x squared is 1. Usually that is the case, though sometimes there is a coefficient in front of the x squared. Sometimes there is a number in front of there. The B in this case is -4, and the C in this case is 5. So let's see what we get. Substituting into my formula, -b, so it's -4, plus or minus is my square root. That's the biggie. -4 squared, that's my b squared, minus 4. Now in the first parentheses, I put the a, which is 1. And in the second parentheses, the c, which is 5. And this is all over 2 times a, which is 1. So now all I've done is taken these numbers and stick it into the formula. And basically, all the solving of the quadratic equation comes down to is sticking numbers into a formula and then simplifying. So first I have a negative times a negative, because of the -4 becomes a +4. Okay, then we have this plus or minus. Okay, here's where I have to be careful. -4 squared. Remember, when you square a number, -4 times -4 becomes +16. And this is -4 times 1, which is -4. And I'm sorry, and -4 times 1 is -4 times 5 is -20. So this becomes 16 minus 20. So I get a square root of -4. 16 minus 20, be careful with this signs. It's the most common errors is to make a mistake with the sign. And on the bottom, 2 times 1, which is 2. And what I see happened is in my radical, in my square root sign, I have a negative number. That was because this became 16 minus 20. But now I know how to deal with square roots of negative numbers. A square root of a negative number is, I break it up into the square root of 4 times the square root of -1. Remember that? We break it up into the positive number times -1. Now the square root of the square root of 4 is 2, and the square root of -1 is our new number I. In other words, this comes out to be 4 plus or minus 2I divided by 2. And if you wanted to put this in A plus BI form, you would separate it and you do 4 divided by 2 plus or minus 2I divided by 2. Now 4 divided by 2 is just plain 2. And 2I divided by 2 is just the 2's cancel out. So my answer is 2 plus or minus I. In this case, the other case, we got just a square root, but the square root was a positive number. It was irrational. This turned out to be not irrational, but not real, a complex number. If you wanted to, you could write it separately as 2 plus I for one answer and 2 minus I for the second answer. So you could write it either this way with the plus or minus sign or 2 separate signs. I'm showing you this because, again, on a final exam, a multiple choice question, it might give the answer in this format or in this format. They're both the same thing and they're both acceptable. Is this clearer now?
Yes.
Cheryl, is it clearer now? Cheryl? No. Can you want to tell us where you ran into difficulty? You can't see it? Is it because I'm using the blue pen? Well, Tuesday better have better markers. They're all. You have to practice more. Okay, so we have time to do another problem. And I'm going to give you time to try it, and then I'm going to do it. Let's do one more problem. Okay, so here's the next problem. We have 5 x squared minus x minus 1 equals 0. And I'll start you off by just telling you, let's just write down what the A, the B, and the C is. I'm not even going to try to factor this because anytime you start with that, it just gets complicated. Anyhow, we want to practice, even if you could factor it, you could always use the formula. So let's say, what would our A be in this case? So that would be the number in front of the x squared, which is the 5. The B would be the number that's in front of the x. Now, there's no number in front of the x. It's just a negative, so we know it's -1. And the C is also -1. See if you can use the quadratic formula to solve this equation. Here are your A, B's, and C's. We'll do that together in a minute.
Professor,
Yes.
I'm looking at the problem from the one before, and you lost me when you added the I.
Okay, let me go back over here. I'm gonna erase this part so I can kind of, right, are you okay till here?
Yeah, it's just the part with the eyes.
Okay, so I'm gonna erase this so you can see that more clearly. After we figured out what was on the inside the square root, it came out to be a -4. Now, a negative inside, we really, until yesterday, said it's impossible to have the square root of a negative number. But yesterday we introduced our new number system called the complex number system. And whenever we had the square root of a negative number, we rewrote it by doing the positive number, which is 4, times -1. This -4 is 4 times -1, correct?
Yeah.
Now, what's the square root of 4?
2.
2. So that's okay. What's the square root of -1?
Stays the same.
No, what do we say? Whenever we see the square root of -1, what are we going to use? That's the new number that we talked about. That's I. The square root of -1 is always replaced by the new number. That's the number that we didn't have until yesterday. This new number, we couldn't, I don't know why they didn't think of some special symbol, but they said, okay, let's just use that for that new number. Until now, we had 10 digits, 0 through 9. Now we have a 10th digit, an 11th digit, this new digit, this new number, I. And that we use whenever we come across the square root of a -1. So therefore, this became 4 plus or minus 2i. Are you following me?
Yeah.
Okay. Anytime you end up with a negative inside your radical, then you're going to want to change it to a positive number times -1. And the square root of -1 is always represented by this new number I. That's why whenever we come across an I squared, since the square root of -1 is equal to I squared is the square root of -1 times itself. That's -1.
Oh, okay, I get it. We got to turn the negatives into a positive when it's in the.
So when you see this square root of a negative number, it's going to come out to be the square root of the number, which is 4 is 2, and the -1, that's where your I comes from. And only when you have I squared can you replace it with by -1. Otherwise, you've got to leave the answer with the I in it. Are you following me?
Yeah, I get it. I get it.
Okay, great. Okay. So, let me, where are we up to? Oh, we were on that question. Okay. Now, can I erase this problem so we can work on that one?
Yeah.
Okay. Does anybody want more time to work on that? Okay, so let's work on it together then. Again, here is my important formula. -b plus or minus the square root of b squared minus 4a squared, ac, divided by 2a. And we set that our a is 5, our b is -1, and our c is also -1. There's our formula. Okay, let's see what we get. So now I'm gonna substitute it in. It's -1, -b, plus or minus the square root of b squared. So that's again my -1 squared minus 4. Now the next thing I'm going to put in is my a, which happens to be 5. And then the next number I'm going to put in is the c, which is -1. And this is all over 2 times a, and again, that's a 5. All I did was take these letters out and replace them with the numbers that I had written over there. Okay, let's simplify. -1 becomes a +1. Plus or minus. Okay, here's the biggie, the square root. So let's be careful. -1 squared is -1 times -1, which is +1. Now I've got to multiply these three together. -4 times 5 is -20, times -1 is +20. I just multiplied -4 times 5 times -1. So that this turned out to be 1 plus 20 in here, which I add up to 21. Notice there's no negative. It's not going to have any i's. The only time I get an I in my answer is if this number works out to be a negative number. And that's all over 10. Now, in this case, I can't even simplify. The square root of 21 can't be simplified because 21 only is multiplied, the only factors are 3 and 7, that neither of them is a perfect square. And you could just leave your answer like this, or again, you could separate it as 1 plus the square root of 21 divided by 10, and 1 minus the square root of 21 divided by 10. Either answer, this with a plus minus or with a just separated. Remember that that plus over minus means there are really two answers. One answer when you add the square root of 21, and one answer when you subtract the square root of 21. So I like to leave my answer like this, but sometimes you will see it written like this. Is it clearer now? Notice again, the 21 is not a perfect square. It couldn't be simplified, so I just left it the way it was. Any questions? Cheryl, did that come out clearer to you? Okay, great. All right, you know what, it's 11:30 already, so I think what we should do is, um, let's leave this here. I'm not going to give you homework I'm going to probably send you homework on Sunday, maybe for Tuesday, but the thing I want you to concentrate on is to do the quiz. Does anybody have any questions on that Delta Math quiz? Again, all that we were doing here today is not on that quiz. This is all new material. So we're going to be continuing our study of quadratic equations on Tuesday. Very important study. I'll give you a few examples to try on Delta Math probably before Tuesday, but that's where we're going to start after the weekend. Okay, have a nice weekend, everybody. Make sure you do as much of the homework assignments that if you're if you're not on par. Again, if you need me to give you an extension on anything, just let me know.
Have a good weekend. Stay safe.
Melissa tutoring.
Yes, you too.
Thank you, Professor.
Be well. Have a great weekend.
You
Okay.
too.
Is Melissa tutoring today?
Melissa, are you going to be having a session now?
You said you don't have no personality.
She should be on now. Melissa? I'm gonna leave now. And
Hi, Professor. There's a question for my classmates. Do y'all still have that WhatsApp group?
you'll have to ask them.
Yeah.
Okay. Can y'all add me on there? I'm gonna put my number in the chat.
I think the person who made the group chat has to add.
Oh, who made it?
I think it's Stacia.
Yeah.
Oh, okay. Is she here today?
Yes, she certainly is. So,
I don't believe so. I'll text her.
All right. Thank you, April. Thank you,
Thanks.
Kashira.
All right. No problem.
No problem. Professor,
yes.
is Melissa going to tutor today? Because I need her help.
I don't know why Melissa, she usually.
Oh, Devonna, Devonna, you gotta send your number.
And I also wanted to know, what was your why that pushed you to Chairman 25?
Yeah.
Okay, Melissa?
Yeah. Can you hear me?
Yeah, I can hear you.
Oh.
Are you, are you having tutoring right now?
Sure, hello.
Yeah, she's staying on. I'm going to leave, but she's gonna stay on. So, I think it was Kashira who was asking. Okay, so there is tutoring today. Have a nice weekend, everybody.
Okay. Have a nice weekend, Professor. Thank you.
Melissa,
Yeah.
can you go over the dividing rationals?
Writing rationals?
Yeah. Dividing rationals.
Oh,
and-
dividing. Okay.
Yeah.
You have like a question on you?
I'm just confused on how to do it.
All right, let me go look for one. Okay.
Okay, so you got a job, you got kids. Okay, cool. So, I mean, do you feel like if you don't start doing this, do you feel like you're ever gonna get your time back? Like, I'm asking questions like that rather than just, you need to do this or else you're not gonna have time. I'm like, okay, best, so you don't have time. That's what's up. So, I mean, let me ask you, you feel like you don't start plugging in, how would you ever get your time back? And then they have to look at themselves and really, to have that self-reflecting moment of, okay, yeah, I'm not doing what I'm supposed to do. Like I get somebody to tell me their goals, and then I'll get them to tell me their daily method of operation, and then I'll let them know that their daily methods of operation is not in alignment with their goals. And now it's like it's not a tough conversation to have because I'm not bossing you around. I just asked you some questions, and you told me the answers, and I just gave you my perspective. So phone calls is just about.
Okay, so this is what you, let me see if I can write it.
And it's the craziest thing in the world, but this is how humans are. Like, just stuff their own way. And that's why you gotta come in with that sympathetic tone. Like I close people on taking action the same way I close them on the phone. It's the same way I close them into the business. It's the same way I close people on taking action. It's just, it's cool, calm, collected. It's all about you, sympathetic towards the situation. And then, you know, as we develop the relationship, I can pick up the phone like, yo, y'all BSing, bro, let's work. You feel me? But in the beginning, I'm all, you know, I'm not too pressuring in the beginning. And that's just me. You know, I know other people where they are very firm and solid and you know, blunt. And, you know, it just depends on your audience, you know. But that's what I would say. Just come off very sympathetic to the situation, but also add more perspective so that they can see that it's still their fault. So like I never want to just come off as somebody like, you know, yo, it's all you, it's all your fault, da 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 da. But I'm gonna be sympathetic towards the situation, but at the same time I want you to understand like, you know, nobody cares at the end of the day. Like I'm sympathetic towards it. Like, you're going to be 40 years old, and nobody gives a damn about your business. Like take that. That's just day by day. And oh yeah, you said what was my why? That pushed me to 25. My why was just honestly I wanted to see other people level up. Like, you know, I mean, once you go chairman, it's not very difficult, in my opinion, to go see 25. It's just all right, taking something off of yourself. So
That problem you talking about?
you know, he just have the ability.
Yeah.
Okay.
Because I need help on how to divide rationals, how to multiply rationals. And there's something about let me see if I can find it. I think it's LCM, the least common multiple, that I need help with.
Okay. I think the reason you have a problem with this is because you're looking at it as a big problem.
Yeah.
Right? So you want to, you know, when you divide it, use the key change flip, right? That's the first thing you got to keep in mind. Keep change flip.
Probably not thinking about it from a place of gratitude, but probably thinking about it from like, man, I'm close. Why can't I just get it, right? And you're sending out a message or sending out frequency. You don't have it. And one thing that has like, and you might think you're working hard, but in reality, you're working against each other. Because one side says you want it, but your thoughts is saying that you don't have it, and you kind of canceling out your progress. When I actually took C25, I wasn't thinking about it. I was aware that it was coming, but I wasn't really thinking about it. I was just in a
right. That's the first thing. So when you have problems like this, you want to just look at it as a small problem, because if I just give you x squared minus 3x minus 10 and say work it out, what's the first step you will do?
Factor and the factor.
Do I gotta find something that adds to 3 and multiplies to 10?
Yeah.
Okay. Let me see.
Realize it's just the title. It just doesn't mean anything. All you gotta do is
So you have an x here. You have an x here. So two numbers that when add multiply would give you negative 10, but when add give you negative 3.
Oh, 5 and 2.
What's the sign?
So I think it will be -5 and +2.
Easy.
Okay, okay, okay.
Oh, you ain't raising your hand.
Easy, easy, easy. Boom. So I just factor at the top. The same thing you're doing for the bottom.
Okay, anybody else? Anybody else? Anybody else? Anybody else?
So the bottom will be is it
Two
4?
numbers that would give you -4, but I had to give you 4.
Anybody else?
Oh, 2 and 2.
Negative.
What's the sign?
So -2 and +2. I think.
Mm-mm.
Stay so attached.
Uh,
How do I stay so attached, or how do I not stay attached? How do I not stay attached? Like emotionally attached?
Because you want a +4, but a -4. So
oh,
negative and the negative, when you add them, will give you that same negative, right? But when you multiply them, they become positive.
Yo, I have chairman 50.
and then I know the right side, it has to be flipped.
Mm-hmm.
The x minus 2x on top and the x minus 5 on the bottom.
Right? We gotta factor this one out though.
Which one?
The one at the bottom right here. So x² minus 2x. How do we factor that?
X -1 and x +1, I think.
Mm-mm.
X bracket X minus 2.
Because it's not like this one. You're just taking out the common denominator of the common of this. Because this is x² minus 2x. The only thing common in this is just the x. Because if you put them back, like multiply them, x times x is x², x
Okay.
times -2 is x2. So you always want, whenever you expand, if you multiply them out, you should get back the same answer.
Okay.
And then there's nothing to really factor out here. So you just put back the x minus 5.
Okay.
And then you cancel out. What could be canceled out?
So
Right.
minus 5 and x minus 5, x minus 2 and x plus 2. I have a question. Do we cancel out the x2 because of the x plus 2 or no?
No. So this x, there's the only way you could cancel it out is if there was an x outside of one of these parentheses.
Oh, okay.
So now what's left at this top? I like putting that, if there's a single x, I like putting it first. It just looks better.
Yeah.
But it's the same thing. And then put back the x plus 2. Over x minus 2. Wow. And there's nothing else to cancel out. So that would be your answer. Hold on, I'm coming right back.
Hi, good morning. I just want to ask, feel discouraged with the things that you do other than people lift your spirits up?
Like you're not in control of everything. So is whether or not you're gonna dwell on a negative thought.
All right, sorry. So you understand everything, or you want me to go over it one more time?
Okay, so that's the final answer.
This.
Okay, I get it. I get it perfectly now.
You know,
So
all day.
When I'm multiplying a rational.
multiply.
Mm-hmm.
Let me find one.
Okay.
Thing that really stops people is the fact that they'll let one negative thought ruin their entire day. So your goal is to not let one negative thought drag out to a negative day. So people are not really discouraged.
All right, but so like with all these problems, as I said, never look at them as a big problem. Because you see how easily when I told you, just think about the top, then think about the bottom, think about the top, and think about the bottom. It got a little more easier.
Yeah.
All right, hold on, let me clear this. Here we have 3x over 2 times. I should
Yeah, thank you so much. I appreciate that.
I should have gave you a harder one, but let's just yeah, this one easy. I do the other. Huh?
There's a harder one?
Girl, this is mad easy. Right? Let me tell you, right? As I said, you're not looking at this as a big problem. You can do this both ways. You can do this 2 ways. You can do it the long way, or you can do it the short way, right? The long way would be times in this, times this, times this, times this, and then break it down, right? Or you can do it the short way by canceling out before you multiply. Because we can what? We can divide crossway, we can divide I would say long way or this way, right? So I know 2 and 2 can go into 2, right? That's 1. Regular division, right?
Yeah.
I know 3 goes into 9. How many times?
3 times.
3 times,
Three.
right? I know if I have x squared into x, I take this way because that's 1x. I put it in here. How many x is left?
1.
1. And then I multiply. 1x times 1 is what?
X.
1x.
X.
3 times 1 is 3.
Okay.
Okay. All right, say that one more time.
So we cancel out, which is cancel out 2 and 2. We got 1. 3 into 9 is 3. And then we gotta cancel out the x.
Yeah, because right here we have 2x here and 1x here. X into x. You basically say, okay, if I have 2x and I take away 1x, how many x is left?
1.
1. So you have to put the 1 here.
Okay.
It's just like if I had, sorry, that's a badass x. I don't even know what the hell was that. If I had like 4x, right? Over x3. This x can go into this x, right? So we already know that. But now we focus on the numbers. If I have 4x, but I have 3, take away 3x, how many x would leave?
1x.
1x. Just like if I had x30, subtract x, we'll divide by, let's say 4. How many x would be leave?
26. 26.
Yeah. Ketira. Ketira. I said your name right? I don't know, I butchered your name.
My name is, I don't know. I don't know why I was named that.
Yeah, so you understand?
Yeah.
All right, cool.
I don't know if it's, I gotta find it because there's this problem that I do not get nothing of it.
It's the multiplication one?
No, it's a thing. Oh, okay. So basically, let's say I have a 5/6 power and then 7 to the 7 power. Something about the exponents. How I gotta find it.
Okay. All right, so let me give you a more difficult one with the multiplication one, because it's really the same exact thing like the division. The only difference is the division you're flipping and the multiplication you're not flipping. Right? So you realize it's the same exact thing like the division, but all I'm not doing is I'm just keeping everything how it is. So do the same exact thing. How do you factor the top? By finding two numbers that would give you -8, but I had to give you what, 12?
Six and 2.
What's the sign?
6 and -2.
Yeah.
Yes.
Would it be x -6 and x +2? Or -2?
-2 plus 6.
The signs are going to be really important for you guys. How do you factor at the bottom?
Don't tell me.
-2.
It would be
X minus
parentheses
6. Yeah, X -2.
8 and 2.
What type of thing is this?
It's a square, so I think it will be.
Yeah, that's how I have it. X plus 4. X -4.
Oh, it will be x parentheses. -8 and x parentheses 2.
X
What
plus 4.
type of fraction? What type of factor is this?
X.
What's this 16?
Difference of 2 squares. That's it.
Okay. What? You don't have a nickname? Katisha?
You
Call
say
me
K, just call her K.
A, I guess. That's what
You
people
say K.
AK, right?
Mhm.
Yeah. So right here, right? This 16 is represented as what?
Oh, 4.
It's a square number, right? It's a square number.
Difference
So
of two square.
the difference of 2 squares. So it's gonna be 4.
X plus 4. Mhm. One, does one have to be plus?
Mm-hmm.
Okay.
How do you factor at the top?
Mm,
The
It's just
bottom is like
common.
that.
What's common in the 4x plus 16?
the 4.
4.
So you factor out the 4.
4 in.
And then parentheses X and 4, 8 plus 4.
Mm-hmm. How do you factor at the bottom?
Um, 2 and 2. -2 and +2. Both of them -2.
Mm-hmm.
I gotta remember that.
It's the signs for you because you have the right concept, but you get messed up with the signs. Just keep in mind the signs. If you have a negative here and a positive here, both of these gonna be negative.
Okay.
Because when you add them, you're gonna get a negative, but when you times them, you need a positive.
I. So then we cancel them out. The x minus 2, the x minus 2, and then the x plus 4 with the x plus 4.
That's it. Then you multiply 4 times the 4x, so you put the 4 outside over the x minus 6.
And
then you put what's left. And then since something else can cancel out, this would be your answer.
all right, I got it. Okay. Is there a thing that we gotta how we subtract rationals?
This this said nothing really to it, but I can find a problem.
All right, yeah, that would be nice.
Subtracting rational.
Yeah.
All right, so on my back. Yeah. All right, same exact thing, right? But the difference between the division, you're not flipping anything. And the difference between the multiplication is you're not really multiplying anything, right? But the same workout applies for these type of fractions, right? So we're gonna put back the x because we have nothing at the top for the x, right? To factor out. But we have a lot to factor out for the bottom. Right? Wow. So how do you factor out the bottom?
1.
Oh,
My bad. I was writing it. 7x.
no, it's fine.
Parentheses. All right. What goes into 20 and 9? 5 and 4. X plus 5 and x plus 4.
Said x was 5.
Yeah, and x plus 4.
It's 5. Same thing over here. Right here.
Um, 4 x plus 4 and x plus 3.
Okay, bet. So now this is the difference between the adding and the multiplying and the division with the adding and the subtracting. Now you have to turn these into common denominators, right? You have to get rid of the denominators. How you do that?
I don't even know.
I got you right now. I'm just attempting to get the beeping sound because I know you guys can hear it.
Oh, no, take your time.
I'm sorry, guys. It's a group chat. You're going crazy. All right, bet. So now what you got to keep in mind when you add, they subtracting or adding, you have to have the common denominator. So with the common denominator, you have to realize that, okay, the x plus 4 is common already, right?
Mhm.
But what's not common with this?
X plus 5 and the x plus 3.
Exactly. So right here, boom, LCD.
Oh.
So you have to come here and tell and state that your LCD is going to be all right. So your LCD is going to be everything that's there. X plus 5. Right?
Mm-hmm. And the x plus 3.
That's 4.
The x plus 3. And you write the what? X plus 4 once.
X plus 4. No, minus.
Sorry.
Whoa,
Right?
whoa.
Because look, you have the x plus 5, right? You have to write everything once.
Oh.
Everything that's in the denominator once. So I got my x plus 5 once. I got my x plus 3 once. I got my x plus 4 once, even though it appeared twice.
Okay.
And then once you take a note of it, once you make your LCD, you put it at the top of the numerator. So now I'm basically writing all of this at the top of my numerator now.
Just on the numerators?
Hmm?
Just on the numerators?
Yeah. Because the whole idea is to cancel out the denominators.
Okay.
Same thing up here. Okay, bet. So let's just recap before we do anything. So we got this problem. You say, okay, boom, I know how to factor out this, right? So you just factor out the bottom. Then you just have to remember that you have to look for the LCD. The LCD is going to come from the denominator that's already here, but you're going to write each denominator once. So write the x plus 5 once, the x plus 3 once, and the x plus 4 once. After you get your LCD, you're going to just simply put it on the numerator. To say I'm canceling out the denominator, how you do that? So we have the x plus 5, we have the x plus 5, so that's cancel out.
Mm-hmm.
We have the x plus 4, we have the x plus 4, so that's cancel out. So what's left here on the top is x.
And x plus 3.
And x plus 3. Right, subtract. We got the x plus 3 over here. And the x plus 4 over here.
And now what's left
is the
x plus 5.
And then what we do? It's a regular, it's a regular what? Equation now.
Yeah.
Wow. So now we multiply. So that's going to be what?
X squared.
Mm-hmm.
Oh, we have to
x times x. X squared. And then x times 3.
3x. X squared
Positive.
3x.
Mm-hmm.
And then we subtract it.
Then we say negative 4 times x.
Will be negative 4x. 5, 10, 15. Plus, minus 20.
Minus 20. And then what we doing with these in the middle?
We add them. 3 minus 4. Oh, we like.
Give me what?
Wait, what? X squared. So that would be the answer?
No.
There's more?
There is more. Because right now, what does this look like?
We equal it to 0?
No. You have to factor out this.
Oh.
So what would give you -1 but -20?
5 and 4. And
Oh, 5 and 4. So it would be -5 and +4.
Mm-hmm. Right? So now you have that x minus 5 and x plus 4, right?
Mm-hmm.
Now you got to put it back over to what? The LCD.
Wait, so x minus 5, x plus 3, and x plus 4 goes underneath it?
Mm-hmm.
All right.
Right? And then you just cancel out what can be canceled out.
The x plus 4, that's about it.
So this right here will be your answer.
X minus 5 over x plus 5, x plus 3. Got it.
Yeah. So like with the adding and the subtracting, it's a little bit more than the division and multiplying, but it's this, you're legit doing the same thing that you've been doing all this time, but now you're just putting it in one. Because we didn't do anything new, right? We factored the AC method, right? Then on a regular division, we'd have to find the LCD. The LCD is just all of these put together. We cancel out. We wrote what was left, which was just a regular equation. We multiplied out. We got back a AC method. We factor it out. We put it back over the LCD, and then we cancel.
So it could be left like x squared minus x minus 20 over the denominator. No, okay, then. Okay.
Okay, I get it now.
Because they always gonna want it in the simplest form.
Okay.
Okay, how about when it's solving quadratic? I think that one has 2 answers.
Solving quadratic equations.
Like for example, I have x plus a over x plus 3 and then equal to 4 over x.
All right, let's do that. All right, you got this? I'm gonna clear it. Say that one more time.
Okay, x plus 8 over x plus 3. No, x plus 3. Equal to 4 over x. It says on my notes that is a solving quadratic, I guess.
So you just cross multiply.
But do we get 2 answers? Because here I got 2 answers.
I don't know, whatever it gives me after I cross multiply. Because there's 2 fraction in front of an equal sign, so you cross multiply. So that's gonna be
equal
x.
to 0, I guess.
No, there's no equal to 0.
Wait, what is this about?
I got x plus 8 And you put it over 4 x times 3.
No,
And
what
then
I got is that it will be x plus 8 parentheses x equals to 4 parentheses x plus 3. And then we solve it and get x squared plus 8x equals 4x plus 12.
yeah, that's what I'm doing right now. No.
Okay.
So I cross multiply and I got 4 times 3x. So 4 times 3x. And x times 8. And now I'm going to what? Multiply. Multiply. So x times x is what?
X
Squared plus 8 over
Plus 8x.
8x plus 4x plus 12. And that's your answer.
It keeps going.
Hmm?
Yeah, that's what I'm trying to say. It will have like negative 4x minus 12 equals negative 4x minus 12. And then it will equal it to 0, which is x squared minus 4x minus 12 equals 0.
What?
I think it's a quadratic.
Unless you told me how to, unless you said this wrong, but this is just a regular, like really a regular problem.
Okay.
Cause like, as I said, unless you told me something wrong, but like this is like 2 fractions between an equal sign, you just cross multiply and then multiply it out. But say what you were saying. Let me see something.
Okay. After what's the solve? It will be. Oh wait, minus 4. Okay, it will be minus 4x. But my minus 4x is underneath the 8, I think. So it's probably that.
Where did you get this problem? All right. So this is the problem that you have, right?
Yeah.
So you have x plus 8 over x plus 3 is equal to 4 over x.
Mm-hmm.
After that, what do you have?
I have x plus 8 parentheses x. Like the x has its own parentheses.
Okay.
So it will be x plus 8 and then parenthesis x. The x plus 8 is also in parentheses, by the way. And then it's equal to 4 parentheses x plus 3. Parentheses x plus 3.
Okay.
You get what I'm trying to say?
Yeah.
Oh, okay. So what that will be called?
I don't know. I see what I think I did this one wrong. No, let's see. Okay, yeah, I did it wrong. I was thinking about something else.
Okay.
Yeah, my bad. So So yeah, the same x, even though yours in parentheses, it's the same thing like how I have it on the board. Sorry, my bad. And then you just multiply out. Same multiplication, right? So it's gonna be x squared plus 8x is equal to
Plus 12.
plus 12. Then, because you have the x squared here, you have to realize that now you have to bring all of this over here to equal it to 0.
Yeah.
Yeah. So you're turning it into just like how you did the AC method, but now you're equaling it to 0. So this is gonna become an AC method, right?
Mm-hmm.
Right. So 8x minus 4x.
Minus 4x.
Positive 4x. Cat the sign of the bigger number. Right? Same thing here. Just got to bring the 12 over here. Subtract 12 on both sides. There's nothing to subtract this 12 from, right? Everyone with me, right?
Yes.
Yeah.
Mhm.
There's nothing to subtract this 12 from, so we just have to write it back.
X squared plus 4x minus 12 equals to 0.
Right? So we cross multiply. We have to realize that because there's an x squared here, we gotta now realize that it's gonna be a quadratic equation. So you gotta bring everything over to this side, equal it to 0. Then we realize that it's gonna be the same thing that we've been doing all this time. Find two numbers that will add to give you 4, and subtract to give you 12.
Six and 2.
Huh?
6 and 2. So
What's the sign?
6. Are they both negative?
6 plus 2.
Are they both negative?
Mm-mm.
Okay, so
Minus
one negative
6.
and positive.
Which one of them?
-6 and +2.
Really?
Plus 6 and
Positive.
minus 2.
Oh, okay. I get it now.
Positive
+6
6.
and
Mhm. is equal to 0. So now because it's equal to 0, you have to equal these two now to 0 to find x.
So then we cancel 6 on both sides equals to 0 here.
So x is equal to
-6.
To -6.
okay.
And then add 2 on both sides and x will equal to +2.
And that's your answer. Hold on, guys, I'm coming. My bad, guys.
Okay.
You good?
All right. So cross multiply, then multiply out. Realize that because there's an x squared, it's automatically going to be a equation problem. Then you bring everything over to this side, equal it to 0. Factor out normally like an AC method. And because it's equal to 0, you have to equal the both parentheses to 0.
Right here.
How do we solve linear rationals?
Say that one more time.
How do we solve linear rationals?
I got you. You said linear.
Yeah.
Oh, okay. Oh, yeah, so she probably know.
All right, I'm only seeing like linear equal.
That's like luxury area right there. When tourists come up, they go over there. Nice over there, man. Real nice. Oh, yeah. All right, guys. Sleep tight on the bathtub. Yeah, sleep tight on the bathtub. But once they finish fixing that, we're gonna come back and check it again. All right, yeah, that was Thank you.
I'm really only seeing linear equation, so. Oh, this was it.
Oh, that was one?
Yeah.
Oh.
I can do one more for you, but this was it.
Okay.
Shirley, we good?
Yes, I'm good.
You don't have a problem? Or we
No, I'm learning.
okay.
I'm getting into it.
Right, boom, right? So that's the problem, right? Does someone else write down the problem?
I wrote it.
Okay, I got you right now. All right, so what I'm gonna do, I'm gonna change the color and see, look at this. So I'm gonna put this over 1, right? So the last one, it just had 2 fractions, right? This one has a whole number. So we can't really solve it like how we solved the first one, right? We have to go straight to the LCD for this one. What would be the LCD for 6, 1, and 8?
24.
24, right? Because 6 can go into 24, 1 can go into 24, and 8 can go into 24. And that's what we're gonna do. We're gonna now times this 24 by the numerator. Right, so far so good?
Yeah.
Then we're going to divide 6 by the 24. So that's gonna give us what?
4x plus 8.
4.
1 into 24. 24.
Wait, I'm lost.
All right, well, we lost it.
Why there's an 8?
All right, so let me go back. Okay. Right, so now we divide, we're putting the 24 at the top, right? Anytime we have the LCD, we always put it at the top of the numerator to cancel out, right? So now before we go on, we're going to cancel this 6 into this 24. So 6 divided by 24 will give you what?
4.
6 into 24?
Yeah.
Oh shit, yeah.
Yeah, because you put 8. That's what I was like, wait, what?
Bro, don't worry about me.
Okay. Thanks.
Don't worry about me, bro. Don't worry about me.
Okay.
1 into 24. I was, I'm so focused. I was, yeah. Yeah, this is gonna be 24 and then 8 and 6. 8 into 24.
Three.
Hmm?
3.
3.
Yeah.
Now, all we're doing is times and these by everything. So we have 4 times x. Oh, that's an ugly x. Thanks. Plus 8 plus 24 times 3 is equal to 50 times 3x plus 8.
So basically, we just put the number that divides in that number, and we just put in an equation.
All right, so I don't understand. I don't even think you understood what you just said.
I don't.
All right, so where are we at? Because I'm here.
Yeah, I'm there too.
So we're just multiplying out. So 4 times 4x.
Plus 32.
4 times 8. 4 plus 8. 4 times 8. Plus 23 times 4.
72. 72.
Oh. Yo, he scared the Jesus out of me. Bro. Bro, I just almost fell.
Wow.
Fell sitting down.
Yep.
How?
Oh my, because
You blocked
that's
out?
how big the news was.
Oh.
All right, all right. Okay, so right here. Yo, it looks really good though. All right. So obviously you're gonna add this and this. So that's gonna be 4x. You see how easy it is?
Mm.
Once you pass this.
Yeah.
Okay. X plus 24.
So this is gonna be negative what?
80.
Oh, I got 128.
128 from this?
Yeah, because what I did,
Jahan.
I thought we had to add just the 4x and the 9x and then the 104 and
No,
the
you have to add this first.
yeah,
So 32 plus 72 give you what?
104.
Yeah. And then you have to now subtract the 104 over to the 24.
Oh, I didn't cancel it out. That's why. What I did was I just looked at the 4x and the 9x and the 104 and the 24.
Mm-mm. Because remember, once you bring this over, once you bring anything over equal sign, the sign has to change.
Oh, okay, okay.
So like now I'm bringing over this 9, the sign changes.
See, I was always confused on that. Like, I would ask myself, when do we add a
Change the sign.
vector and when do we cancel it out?
Say that one more time.
I always get confused with that because I wouldn't know when do we add it like how I did it or when do we cancel it out. Cancel it out.
Um, I think that will something like this will help by not looking everything so big. So you realize I only focus on one side, and then I move to the second side.
Then it will be -5 equals to -80.
-80. What? Say that one more time.
Would it be -5 equals to -80?
Yeah. negative 5x equal to 8 negative 80. Oh, that's ugly. So just to find x, what we do?
Divide -5 on both sides.
What x is equal to?
60. 60.
And that's your final answer. So with this one, right, you just had to find the LCD, right, which is 24. Then you times the 24 by the numerator. Then you cancel out the denominator. Then whatever answer you get, you're going to multiply it by the numerator. Extend the numerators by multiplying them out. Work on one side. Then you always bring the x over to the left side because it's a little bit easier, right? So that just means that everything that don't have an x should be over to the right side. I like to work on my numbers first, but some people like to work on the x first. It's the same thing. And then we solve for x.
Got it. I'm hungry.
That is a fact.
Okay, that's about it.
Shirley, you have anything for me?
I always have, so I let somebody else.
Okay,
go
bet.
today. Yes.
All right, I appreciate you guys.
Yes, thanks.
That was
too.
pretty fun.
Thank you
Yes.
so much.
Have a blessed weekend.
All right, same to you guys.
All right, bye.
Bye.
Bye. Okay.